Welcome back, SurfNav. This is still Walt O'Donnell, one of your SurfNav instructors, and in this video, we'll be continuing on with our PIM problem number 1, 16 November 2023. In our last video, we determined that we were 37 minutes ahead of PIM. In this video, we'll be solving for the speed required to regain PIM by our 0800 GMT waypoint. First, we'll need to figure out the distance between the next two waypoints, and then determine the speed required to get there by 0800 GMT. Let's get started. So let's go ahead and draw our waypoints out again. In the middle here, I'm going to put our 0500 Zulu waypoint, and then since we're transiting to the west, I'm going to put our 0800 Zulu waypoint over here and connect them. Also, over here to the east of us, I'm going to put our fix. This is where we are at 0330 Zulu. And there's our DR, good for good measure, just to show which way we're going. And now let's bring out our time, speed, distance triangle. Let's see what we know here. Now for distance, we'll start with that. From the problem, we know that the distance from our current fix to the next waypoint is 10.6 nautical miles. That's the first part. What we also have to figure out is the distance from that next waypoint to the waypoint after that, our 0500 Zulu waypoint to the 0800 Zulu waypoint. We're going to solve this distance by using two things. First, the difference in time between 0800 Zulu and 0500 Zulu, and our plan speed, our SOA. We remember that our SOA was 12 knots. That was the planned speed. That means that every hour we plan to go 12 nautical miles. And as a reminder, for this part of the problem, we're just looking to figure out this distance. That's why we're using the original SOA here. We're going to do a little math here, and the difference in time between our two waypoints, 0800 Zulu and 0500 Zulu, is 3 hours from there to there. So now we have to figure out this distance between those two waypoints. We're going to do that by taking the 3 hours of time and our speed of advance of 12 knots, and we use our time, speed, distance triangle down here for that. We know the time, that's 3 hours between the waypoints. We know the speed, that's our SOA, our planned speed of 12 knots, and we're looking for distance. So since we know speed and time, we're going, since they're on the same level, we're going to multiply speed and time, and that's going to equal the distance. So our formula for this part of the problem is distance equals speed times time. So in our calculators, we'll take our speed of 12 knots, and we'll multiply it by the time of 3 hours, and we get 36 nautical miles. So the distance from our next waypoint to the waypoint after that is 36 nautical miles. We know that these units are nautical miles because for knots up here, those are nautical miles per hour. When we do the math, these hours cancel out with these hours, and we're left with just nautical miles. So now we'll add these two together. So the distance from us to the next waypoint is 10.6 nautical miles. The distance from that next waypoint to the next waypoint is 36.6 miles. We'll add them together in our calculator and get 46.6 nautical miles. That's from our fix to the 0800 Zulu waypoint. So there is our distance that we're looking for, 46.6 nautical miles. Let's clean this up a bit. So we'll move this over here. The distance is 46.6 nautical miles. Now let's see if we can find the time. We need to find the difference in time between our current position, our current fix, and the waypoint that we're looking for. Not the one in between, but the next waypoint. The one, in this case, the one further to the west. Again, maybe really good at math. You can do it ahead. Great. For those of us who can't, we're going to take 0800 Zulu, the time that we're supposed to be at this waypoint, and subtract from it the time of our current fix, 0330 Zulu. When we do this math, we'll start with the minutes as usual, but you can't do 0 minutes minus 30 minutes, you get a negative number. So we'd have to steal an hour from over here. So we'll subtract an hour from over here. This 8 becomes a 7. And then we'll add 1 hour or 60 minutes over here to the 0, 0. So that 0, 0 becomes 60 minutes. So now when we do the minutes again, 60 minutes minus 30 minutes is 30 minutes. Now over to the hours. 7 hours minus 3 hours is 4 hours. Now we already know that we have to put this number into our calculator. You can't put 4 hours and 30 minutes into a calculator. So we'll take the 30 minutes of time divided by 60, because there's 60 minutes an hour, and we get 0.5 because 30 minutes is 0.5 hours. We add that to the 4 hours, and we get 4.5 hours. That's the amount of time that we're going to use to do our calculations. So let's move that over here. The time is 4.5 hours. So now looking back at our time, speed, distance triangle, we now know the distance. That's 46.6 nautical miles. We also now know the time, which is 4.5 hours. Distance is on top of time, so that tells us that we'll take our distance, divide it by time, and that will equal the speed. So our formula is speed equals distance over time. Let's clean this up a bit. So now we'll do our math. We'll take our distance of 46.6 nautical miles and divide it by 4.5 hours, and that gives us an answer of 10.355. Repeating. For units, these are nautical miles per hour, also known as knots. So that's the speed required to get back on PIM, so 0 minutes ahead or behind PIM, by our 0800 Zulu waypoint. Also, just a sanity check, if that does make sense, we're a little bit ahead of PIM, about 37 minutes ahead of PIM, which means in order to regain PIM, we should slow down a bit. We should be doing a little less than our SOA of 12 knots. Yep, 10.35555 knots is a little less than 12 knots. For rounding, we recommend that you leave it out to 2 digits, like we did. We recommend that you don't round when doing an ETA problem or speed required problem or PIM problem until the very end. And there we go. We solved for the speed required to regain PIM. We found the distance between our next 2 waypoints by taking our SOA and multiplying it by the amount of time between the 2 waypoints. We added that distance to the distance between our current fix and our next waypoint, and then we divided it by the total time that we have to get from our current fix to that waypoint. And we got an answer of 10.36 knots. And just a reminder for our tolerances for step 2, since it's a PIM problem and it's time, we give you plus or minus 2 minutes. And for step 3, which is the speed required part, we give you plus or minus 0.2 knots. And there you go. That concludes our PIM problem number 1 from 16 November 2023. Thank you for tuning into these videos so that you can get better, because when you're on your ships as navs and ANAVs, you'll be doing PIM problems many times a day, and you won't be the only one doing it. You need to make sure that your watch standards know how to do this math as well. As a reminder, there are many ways to do a PIM problem. As long as you show your work and get the right answer, you'll get full credit at SurfNav. If you have any questions about any of the math that we did or any of the methods that we used, we encourage you to bring those questions into the classroom or the instructor bay and ask any SurfNav instructor for extra help. We want to help you while you're at SurfNav, because once you get to the fleet, you're going to be pretty busy and you're going to be doing these a lot. And then as a reminder, PIM problems also show up on the SurfNav midterm and final exams. Thanks again for watching. So this is Walt O'Donnell from SurfNav, and we look forward to seeing you in the classroom.